Today we are reviewing Asteroids by TMBScratch. We are practicing one of the core concepts of creative computation, which is remixing and reusing. By evaluating somebody else's code, we give it more life. One of the best aspects about Scratch is that when you see a game that you're interested in, you can take a look under the hood. But first we're going to play the game. I like the title screen over here. Animated. I'm going to have to check that out later. But let's take a look at the gameplay first. The first thing that I notice is that everything is very well animated, and if you take a look at the sprites, they wrap around to the other side of the screen when they're moving. There's a lot of randomization over here. There's this screen shaking effect every time there's impact on the screen, whether it's the bullets or the ship. Particle effect, counter, everything's done pretty nice. Over here I'm taking a look at what happens when the game starts. It's managed by a broadcast, so I'm assuming that the start button from the title screen will start up everything. And as long as the player is alive, meaning that he's not dead, the player will be able to accelerate and change costumes. There's a big logical statement over here, basically saying that the player will die whenever he touches any of the asteroids, and this will repeat twice, meaning we have a total of 3 lives. Moving on to the next piece of code, it looks like when the player dies, he manages it with a variable, dead yes or no, and there's another variable if whether or not dying is possible, invincibility, what to do when you respawn, and over here on the right hand side there's a lot of code for setting up a shaking variables in decreasing increments, shake X and shake Y, that will go off every time a message is broadcast for something going boom. Over here there's some code for the movement, managed by an X and Y variable, meaning left, right, and up, down respectively, and here's some code that I don't understand. It's a modifier for the left and right and up and down speed, but I don't know what this means. Sine, cosine of direction times 0.3. So let's model it. One of the most powerful things you can do with coding is something called modeling. When there's something that I don't understand, I can make a model of it using computer language and help me understand it little by little. So what I'm going to do over here is I'm setting up something to figure out what this sine cosine of direction means. This little module over here is going to help me see what happens to sine and cosine when I change the direction. My plan here is that I'm going to look at the sine and cosine of direction as I'm changing the direction with my own key presses. And what I hope to figure out is how is sine and cosine modifying the direction. The orange blocks over here are what we're going to monitor on the screen, and we're going to fill them with the same code that we saw that we couldn't understand. So I'm going to fill up these orange blocks with the sine and cosine of the direction and then monitor it. And while I finish this up, let's take a moment to consider how easy it is to speak computer language with block programming. All of these codes are written in plain English. There's shapes to show you how they fit together so that you can piece together the syntax like the computer would expect you. Okay, so you can see here with our initial direction of 90, the sine is 1. As I start to point downwards, the cosine approaches -1. Interesting, and sine approaches 0. Continuing on, when we're facing left, sine approaches -1, cosine approaches 0, and then as we are pointing upwards, cosine approaches 1, and that is how that works. Okay, so here's what I learned from my experiment. When it's moving left and right, sign is close to 1. So the modifier over here is not actually doing a whole lot except for this 0.3 over here. And the same thing for the up and down velocity, or the y velocity, which is modified by the cosine. So first they change the two velocities, they modify them a lot, and then they move the character. And also it wraps around to the other side of the screen, just like the way we did it, except slightly different numbers. You know, I just want to take a moment to mention how well organized all of this code is. The top level, I saw everything that happens when the game starts. There's code organized into neat little modules over here. They all have separate functions. Similar actions are grouped together. As I've gone through this code, all of the variables have been labeled very well, and it was very easy to read and understand the flow of logic from one variable and how they are interdependent with each other. So I really have to applaud this programmer over here for the way that they put this code together. Now we're taking a look at the asteroid logic, and there's quite an impressive randomization machine right here. It goes through a few different iterations. First picking between 1 and 4, picking between 1 and 2, and depending on which gate it goes through, it's going to spawn an asteroid on a different side. I did it kind of a different way. This looks a lot cleaner and I like it better. But we have a similar methodology. First randomization for the spawning chance, and then randomization for the side. Pretty nice. This randomized asteroid target that is invisible and always bounces all over the screen is a really nice touch, because it brings a whole new kind of aspect to the asteroids. They can fly in any which direction. This over here is the code for how the asteroid spawns other asteroids. It sets a variable called split x and split y that they reuse in the other asteroids, and I'm betting that the medium asteroid uses the split x and split y to set where it's going to spawn. So here, just in the last few minutes, I got a lot of great ideas of how to move my project forward, and this is what creative computation and remixing and reusing are all about. Thanks for watching.